Hello and welcome to this video that will help you graph some quadratic functions given to us in vertex form. Before we jump right into vertex form, let's just review the standard form a little bit. Y equals ax squared plus bx plus c. All of these are very similar and yet very different, so make sure you're keeping up with all of the different forms as you're instructed to. Intercept form was a times x minus p times x minus q, gave us our 2x intercepts. And today we're going to talk about vertex form, which is right down there, but it is a times x minus h quantity squared plus k on the outside. The benefit of vertex form, as you can probably guess by the name, is that it gives us the vertex right away without doing any math, actually. And that's pretty nice because that vertex seems to be one of the most important pieces of the graph. A still does what A does. It determines whether our parabola opens up or down. So like we said, we have a vertex of hk. Make sure that when you pull h out of there, you remember that the general form for that is x minus h. So it might be a little bit different. Axis of symmetry is that vertical line, x equals whatever your h value is. A still, like I said, determines whether it opens up or down based on whether it's positive or negative. So not too tricky. This is actually my favorite form because I find it the easiest. You'll have to let me know which one you like best. But here's our first one. We're going to, as always, identify the things we know. We know that A is -1 right there with that minus sign out front. H is a -2 because right inside here, remember that is x minus the -2, as we learned in our formula, and then k is 3. So this tells me my vertex is -2, 3, and the axis of symmetry is x equals your h value. So negative, I don't know why my pen stopped working, -2. Okay, we're going to plot these things and then see how much more information we need based on what we were given. So there's my axis of symmetry at x equals -2, and then I'm going to find -2, 3 for the vertex. And I know this opens down, but I don't have a lot of information there. So if you remember our shortcut of the 1, 3, 5 rule, that gives us more points. It's always right 1, and then in this case down 1, because we move our 1, 3, 5 has to be multiplied by a. So it really should be a, 3a, 5a rule, but it's easier to say 1, 3, 5. So then I go right another 1 and now down 3. So that brings me here. These two new points can be reflected across the x-axis and brought over here. And there we get fairly easily our 5 points required for this parabola. Again, making sure that they are nice and smooth and not pointy at their vertex. Pretty easy, hopefully. Here we have another one, just to try it out because we're having so much fun. Okay. Here, A is -3. Our H is 2 because x minus h, and k is -4. So our vertex, 2, -4. Our axis, x equals 2. And because a is negative, this opens down. In our 1, 3, 5 rule, instead of doing 1, we have to take -3. And then instead of 5, we have to do -15 because these multiply by our A value. So let's put it all on our graph. We have an axis of 2 dotted lines and 2, -4. This will open down, and we are going to have a right 1, down 3. So this is a really narrow parabola. These are the hardest ones. -15 is way off my graph paper, so I'm just going to kind of ignore that. These are the hardest ones to graph accurately because they are so narrow. It's really hard to not make them pointy up here, but like I keep saying, just do your best and it'll work out. So a really narrow parabola down there, opening down with those pieces of information. All right, looking at this one, we have A as -1/4, so that's actually going to be a wider than normal parabola, and it will open down again because it's negative. H is 1, K is 4. So our vertex, 1, 4. Our axis of symmetry is x equals 1. And we can put that on a graph. There's x equals 1. Remember, your arrows are super important here to indicate that this keeps moving as far as we can graph. So we write 1, and then our 1 gets multiplied by -1/4, so I move down 1/4. And then I go right 1, and now I go down 3/4, so I'm going to be to there. And then I go right 1, and now I go down 5/4, which is 1 and a little bit more. So I'm making this sort of parabola. Reflect those points across their axis of symmetry. And there we have our parabola as a nice smooth curve. The wider ones are a little bit easier to graph. Kind of making sense? Not so bad? Sorry about all the scrolling. Let's do one more, and maybe 2. A is 1/4. H is -4. K is 3. So this opens up. It's wider because of the 1/4. We have a vertex of -4, 3, and we have an axis of x equals -4. Graph it. Axis of symmetry. Rulers make that nice, but I don't have one. 1, 2, 3. This is going to open upwards, and we can use our 1, 3, 5 rule again. So I'm going to go right 1 up 1/4, estimating that. Right 1 up 3/4. Right 1 up 5/4. And if you really want, you could continue. Those are enough for me. I'm going to reflect this one over to the left. This point gets 2 to the left. That was supposed to be a little taller. And this one, 3. So it kind of makes that nice parabola, again with arrows on the end to indicate that that goes in that direction forever, never stopping for anything. This should be our last one, just for a little bit more practice, because that never hurt anyone. A is, that's right, -2. What does it tell us? It tells us it opens down and is also narrower, if you want to keep that in mind. As you're graphing, you're going to get a parabola that kind of looks horizontally squished. H, -5. K is -3. So we get a vertex, -5, -3, and an axis of x equals -5. Put it on your graph. Should label this as -10. And -3 right there. This one's going to open downward and be narrower like we said. So right 1 and now down 2, because your value of 1 has to get multiplied by a. Right 1, down 3, but really -6 because I forgot to multiply. So right 1, 2, 3, 4, 5 goes off the graph paper. Estimate that, and then flip them across, reflect them across the x-axis to get those points over there. And just as we expected, this opens down and is slightly narrower than an average parabola. So there is a crash course in graphing in Vertex form. Hopefully this video helps you. Let me know if you have any questions.